Differential equations terminology. In this talk, I'm going to explain all of these terms and maybe a couple of others as well. Actually, I'm not going to explain what differential equations means. I'm going to assume if you're interested in this, you already know that. This list is in the description down below with timestamps, so you can skip ahead whenever you like. In this talk, I'm going to show you how to look at a differential equation, recognize all of its key features, put names on those features, which you can then look up. Maybe in a book, maybe online. I'm not actually going to show you how to solve differential equations. I'm going to show you how to look up how to solve differential equations. A couple of things before we move on. There are two different definitions of the term homogeneous, depending on context, so watch out for that. And also you should be aware that not every differential equation has a solution. Many nonlinear equations do not, and even non-homogeneous or equations with variable coefficients. So quickly here, differential equations come in various types. Ordinary differential equations have solutions in the form of one dependent variable that is a function of one independent variable. You can call the variables whatever you like. X and Y are a popular choice. A partial differential equation is one that has solutions where one dependent variable is a function of two or more independent variables. Partial differential equations have partial derivatives. Ordinary differential equations have ordinary derivatives. A system of differential equations has two or more dependent variables that are each functions of the same independent variable. It's called a system because there's actually more than one differential equation, but they go together in a group and interact in some way. Typically, the number of differential equations is equal to the number of dependent variables. And of course, if you really wanted to, you could have a system of partial differential equations with multiple dependents and multiple independents. Now from here on out, I'm going to stick to the basics and only do ordinary differential equations. So order refers to the value of the highest derivative. So this has a second derivative, y double prime, that makes it second order. Here the highest derivative is triple prime, three derivatives, so that would be third order. If the second order term was not here, then the equation would be first order, which is as low as it gets. Generally speaking, second order is easier than third, and first order is easier than second. In fact, everything up here is easier than everything down here. Now I've written this in standard form, which means the highest derivative is always on the far left. So there it is, and then you work your way down from there. You should always be on the lookout for differential equations that are not written in standard order, because that can mess you up. First thing you should probably do is just rewrite it to get it in standard order. Next up, homogeneous and non-homogeneous. A homogeneous equation is one where all of the non-zero terms have either y or a derivative of y. So there's a y and there's a couple of derivatives of y. These terms down here all have y's in them, but these do not. So these are non-homogeneous terms, and either one by itself would be enough to make this whole thing a non-homogeneous equation. It's standard format to put all of the non-homogeneous terms on the right and everything else on the left. Again, watch out for variations. A common mistake that people make when they're looking for non-homogeneous terms is that they focus on the x variable, because the vast majority of non-homogeneous terms look something like this. It's actually unusual to have a constant. They're usually some function of x. But what can mess you up there is that these have x's, but they're not non-homogeneous. So remember to focus instead on the y's. Are there or are there not y's in the terms? These all have y's, regardless of the x's. Neither of those have y's. Linear and nonlinear. A linear differential equation has all linear terms. Each of these is a linear term, which means that it contains only a y, or a derivative of y, being multiplied by something else that does not have a y. So y times 4, y prime times 4, and then, that's y times 1, whatever you want to call it, but that's linear as well. Now down here, these two terms are nonlinear. Here's a y cubed, that's not linear. And then here's y times y double prime, that is also not linear. This is linear over here, but even one nonlinear term is enough to make the whole equation nonlinear. Now notice what I have underlined. The x squared has nothing to do with whether this is nonlinear. It's all about the y times y double prime. Same story over here. The only thing that matters is the y cubed. Whatever is going on with any non-homogeneous terms is beside the point as far as nonlinear is concerned. Constant and variable coefficients. The coefficients are whatever is being multiplied by the y terms. So there's a 4 times y, the constant is 4. There's a 4 times y prime. If you don't see a coefficient, then presumably the coefficient is 1. Now x squared is not a constant, so it's a variable coefficient, and the same is true for 2x. Regardless of the 2, the x makes it a variable. And by variable, we mean x, not y. Over here, of course, we have a constant coefficient. The constant is 5. One last little footnote on homogeneous equations. So there are two different definitions for the term homogeneous. The first one that I gave you technically applies only to second order and higher equations. A first order homogeneous equation is one that follows this format right here. And there is a special method for solving equations like this, which you would have to look up. So here is one example that clearly fits the format. There's the derivative. Here's our function, and x over y is certainly a function of y over x, so that fits the pattern. Here's another homogeneous equation. This does not fit the format so obviously until you realize that this is actually the same as this. So you are within your rights to fiddle around with equations and rearrange them to try to shoehorn them into a format that you're familiar with. Thank you very much for watching. Please like and subscribe. Also, if you would like to be tutored online by me personally, I am available. There is more information at my website, alternaprof.com, and also in the About page for this channel.